So when you have a Lewis structure, that is actually a two-dimensional or a 2D or a flat shape. It's also called the structural formula, and it is simply the atoms and how they're bonded. So this is another version of the Lewis structure on the left. And what this shows are the bonds. So a single bond is two shared electrons. And I'm going to circle the electrons around the carbon that are indicated as single bonds. So this would be 1, 2, 3, 4 bonds around that carbon that I just highlighted in blue. And each of those bonds has 2 electrons that, let's switch the color, and I show them as red. So this would be 2 electrons in here, 2 electrons in here, 2 electrons in here, and 2 electrons in here. So each of these bonds can be thought of as either 2 electrons or a single line. Okay, so that's one line, has 2 dots, basically. And so those dots are electrons, and the line is a bond. So there are 8 electrons around this carbon, and that was the reason why carbon forms bonds, is to obey the octet rule, which is that carbon on its own has only 4 valence electrons and is not stable. Once these electrons are shared with forming bonds with hydrogen, that's the formation of those single bonds. Now this carbon is stable. And not only is the carbon stable, but the original hydrogens also only had 1 electron, and hydrogens were not stable with the 1 electron. So these hydrogens are now stable. I'll circle that. This hydrogen now has 2 electrons around it within here. So this is those green now. And those 2 electrons, this obeys the duet rule. And obeying the duet rule is only due to the fact that there were bonds, the formation of bonds to the carbon. Okay, and so this is every single hydrogen has 2 electrons, and 2 electrons, and 2 electrons. So those are 2 electrons 4 times is what I drew in green. And so now what you can see here is a big mess, but let's do it on here. So this is hydrogen has 2 electrons per bond, 2 electrons per bond, and then the carbon, I'll do in red, has its 8 electrons. And what you can see are these are overlapping circles, that big mess. And what those overlapping circles indicate are that these are electrons that are shared. So those are electrons in bonds are shared. And that's what we've been saying, is that these are shared electrons. This is a covalent bond. Individual bond, there's 4 of them. Each individual bond is a shared pair of electrons. So from the Lewis structure, we can move on to what's called the valence shell electron pair repulsion theory shape. So from the Lewis structure that's 2-dimensional, we can move on and determine the 3-dimensional structure, or the 3-dimensional shape and 3 dimensions. That's what we're used to, is that 3rd dimension. So this is going to be moving into off the page and moving into the 3D. And so this is starting always with the Lewis structure. You need to start with the Lewis structure steps that we went over in the worksheet, and then this 3-dimensional shape is the true shape of that molecule. So of any molecule, when you start with its 3-dimensional, when you start with its 2-dimensional, this will determine its 3-dimensional molecule shape. Okay, and so here this is starts with the Lewis structure, and looking at, this is going to be slightly different, so I'm going to choose orange, is looking at the central carbon and how many bonds and lone pairs are around the central carbon. Will determine the shape of the molecule. So how many bonds and lone pairs around the central atom, that will determine the shape of the molecule. So this is the three-dimensional shape here. And this is a central atom, the carbon, that I've circled in orange, has 4 bonds. 4 bonds on that central atom. And this is a recipe, basically. When you have 4 bonds on the central atom, this forms a shape that is called tetrahedral. And this tetrahedral shape is basically a tripod. A tripod is a base of 3 with a tall top. It's a tall pyramid, and the central atom has 2 bonds coming out at the top and then roughly off to the side about 120 degrees. And then this is showing this thicker line is coming out front. There's a hydrogen coming out in front of the plane of this paper, and this dashed line means that this hydrogen is going out back behind the plane of the paper or this page or this screen.